Really need like a DJ to take care of things here. Oh, there they are! Yay!
They have a snowstorm going on at their school.
Looks like it.
That frozen princess over there was like
Frozen.
Thank you. Okay, so this is memos, and here's one for Wyatt. And there we go. Morning, we're taking a look at the homework first. All right, homework packet. Absolute value equations is a type of equation that has two answers. And just a little reminder why it has two answers. Absolute value means how far away something is from 0 on a number line. So if I have a 0 on a number line, there's two directions. There's the right and the left, or the positive direction and the negative direction. So in absolute value equations, we need to remember that there's two options. And what we did to help us out with these equations is we would solve them in like the positive case and the negative case. For the positive case, you take the absolute values and just let them go away. The straight lines you don't write anymore, and then you solve for the variable whatever steps you need to do to get the variable by itself. For the negative case, where those lines are, where the absolute value bars are, put parentheses and a -1 in front. That makes this negative 2d. That means we got to divide this time by a -2. D equals -3. A lot of you in your final exam found one of those options and got partial credit for the absolute value piece. Now, some of these absolute values have numbers on the outside, some of the problems. And before you start doing this plus and minus case, you simplify the equation as a whole to get rid of things on the outside of the absolute value. If a number is right in front of the absolute value, that's times. So to get rid of that 3, I divide by 3 here, and I do the same thing on the other side of the equal sign. So that leaves absolute value of k minus 21 equals 3. Now I can go ahead and think about the positive case and the negative case. Oh, thank you. Thank you, Imogen. 6 divided by 3 is 2. Okay, so for the positive case, again, absolute value lines, I can just eliminate them. Take this over. Just this simplified version. Again, I don't need that 3 in front. I divided it through. Now I'm going to add a 21 to both sides. Here's one of my two answers. Now again, I take this simplified form, and that's the one I'm going to find the negative case for. -1 in front of where the two lines are. I put parentheses, and the expression that was inside the absolute value inside the parentheses. I have this 2 over here. So when you have numbers outside, go ahead, divide. In this case over here, to get rid of that 5, because it's added, you would subtract, then do your plus and your minus option. Now, just because we're thinking about these in terms of two options, the positive and negative, or the right and the left direction from 0, doesn't mean answers are both going to be one positive, one negative. Sometimes the way you have to add and subtract, you end up with 2 negatives or 2 positives, okay? But here's the positive version, no absolute values. Here's the negative version, parenthesis with a -1. Now let's finish this one. Distribute the -1 plus 21 equals 2. -1 times k is -1k. -1 times 21. A negative times a negative makes this positive. Now I got to subtract the 21. -19. How do I get rid of this negative in front of the k?
Make it a positive.
Yeah, I want to do that, but how? Divide by -1 on both sides. I can't just change one thing. I got to figure out the root to get it positive and then do it to both sides. So I can divide by a negative, because negative divided by negative now makes this positive k equals -19 divided by a -1 is positive 19. So here's the 2 answers. As you can see, you're probably going to need extra paper that you'll attach later for a lot of these problems. Some of these little ones you can just do on this sheet. Some of the other ones you're either going to need to write small or attach a separate piece of paper. Okay, so first page you know how to do from yesterday. Second page is this absolute value equations. Third page we're going to learn how to do today. And then there's some graphing practice and some solving systems. We might look at those on a different day, but that's a good jump start onto the homework. Again, you're working this homework packet as you have time. I would try and do a little bit each day and come in with questions. If you come on Monday and have 5 or 6 questions, I might not be able to give you time in class. But if you do a little bit each day, then it's not super huge and you have time to get questions answered. All right? Now, we're working on a unit on data, dealing with numbers. Yesterday we had a person who did health research and looked at a bunch of numbers for cereal. What were those numbers for the cereal? Grams of sugar in a serving of that cereal. And we looked at it as one big list and tried to find patterns. Then we looked at it in this dot plot where we kind of just don't worry about names anymore, but just kind of look at the spread of things. And we looked for patterns or conclusions that we could draw. We talked about those in terms of distribution. This is symmetric. Andy, what does symmetric mean?
Like they're like the same.
So what's same about them?
Like you can split them in half and they'll still match.
Split them in half and they kind of match on the 2 sides. Now skewed left and skewed right. Notice that the word right, does that mean your peak is on the right?
The low is in.
No, the low is on the right. Okay? Skewed left, does that mean the peak is on the left? No, the low. So skew means something that's out of ordinary. And the out of ordinary piece, if it's skewed right, it's out of ordinary on the right.
I'm skewed.
Are you skewed a little? Yeah, I am some days too. It's all right. This is just a way to describe data. Is it symmetric, or do you have some outliers off to the side one way or another? All right. So now, a new way of looking at numbers. Again, you're going to use different ways depending on answering questions or the type of data that you have. So another graphical representation, someone to read for us. Thank you, Anna.
Another graphical representation that displays the distribution of missing data is the box and Whisker file. The box and Whisker file displays the data distribution based on 5-member summary. The 5-member summary consists of minimum value of this quartile, Q1, median, the third quartile, Q3, and the maximum value.
Okay. 5-number summary is used to create box and whiskers. Each vertical line on the box and whisker plot represents a value for the summary. Okay, so here's Q1, here's Q3, and here's median, here's minimum, and here's maximum. Those are the 5 numbers. How many numbers?
5.
How many numbers, Christian?
5.
Okay, minimum is the lowest number. Maximum is the highest number. Median is in the middle. Now, median is similar to an average but different. We'll look at why in a minute. And then Q1 and Q3 indicate quarters. Okay, this is 25%. So this is where the 50% are below and 50% are above. At Q1, 25% are below that, and then 75% above. So this is the halfway, this is the first quartile, it's called, and the third quartile. So we're dividing it into 4s. But let's look at some information first. Determine each percent of data. Oh, all right, here we go. This is just in general. I thought they were going to give us some data. Determine each percent of the data value for the given sections on a box and whisker plot, as shown in the worked example. Explain your reasoning for each. So the first thing they want is less than Q1. Less than Q1. What percent of the data is less than Q1?
Third.
Is that a third?
Quarter.
It's a quarter. And what's a quarter in percent?
25.
25%. So less than Q1 is 25%. Greater than Q1.
75%.
The other portion. So here we go. So right here, Q1 is 25% of the numbers fall from here to here, and then greater than Q1, they're talking about all the rest. So if this is 25%, that's 75%. Right now at your table, I want you to do B and C. You're looking at the box and whisker. Put your heads together. B and C, please. Are we doing on time? Here, we'll give you a little more time. We already did it. He was, just not me. That's all right. Here,
Mr. Craig.
quarter. What's percent? Okay, so right here, 25%.
Wait, we were done.
All right.
If you have 100% total and this is 25, what's this? Good. Write it down now. You guys are putting your heads together on B. Is one of those a 2? Good. Make a little line on the bottom of the 2. There we go. So I have a pencil sharpener if you need. Oh no, what happened? Hate that. And you're like trapped for a little bit. Just got a finger that got stuck in the cardboard. Less than Q3. Q3. Now remember, Q is quartile, so these are divided into quarters. So less, these are not correct. The 16 is for Q3. Right? How much is more than Q3? This is the top quarter. Good. So greater than Q3 is 25%. So what's less than Q3? Good. Good. Yeah, these are not correct. Okay, remember, these Q's are dividing it into quartiles, quarters. So I think it might be easier to look at greater than Q3 first. So what's, if this is the top quartile or top quarter, what's that in a percent? Good, that's the greater than Q3 is 25. So what's less than Q3? Good. Did you count lines? Is that where you got the 40 and 60? Oh, okay. So the top quartile is 5%, and the bottom less than, yeah. Okay. I'm going to use color in mine. All right, if I could have your attention up this way, please. All right, so again, these Q numbers and the median, they divide things up into quartiles or quarters. They might not be the same size, because if you have things symmetric, everything will be exactly the same size. But if you have things skewed one way or another, at this point, it might not look like quarters. It'll make more sense when we actually see some data. But one thing to know about Q1 is this is the bottom 25%. That, I think people understood. Okay, that also means that above Q3, this is another 25%. If you divide things into quarters, each little segment is 25%. That also means that right here, between Q1 and the median, that's 25%. And right here, this is 25%. Okay, so again, this is a 5-number summary. 2 of the numbers show you the endpoints, and then 3 of the numbers show you where the quarters fall. Right here, less than Q3, again, I think greater than Q3 is easier to see. So greater than Q3 is 25%. So less than Q3 means everything below, that's 25, 25, that's 3 of the quarters, or what percent?
75.
75%. So less than Q3 is 75%. In C, here's the median. What percent is less than the median? What percent is greater than the median? Hello? What percent is less? What percent? 50 and 50. Now, between Q1 and Q3, here's Q1, here's Q3. What percent is between my
50.
two fingers?
50.
50. Another 25 and another. It's 2 quarters or 50%. Okay, 50%. Here we go. Flip the page. Now, that was kind of vocabulary that'll make a tiny bit more sense when we look at some data. What does this represent? We're going to construct a box and whisker plot for our data in the sugar cereals. Notice we're getting a little tip from this girl on the side. What is the girl on the side telling us to do? Okay, so let me switch this over.